Hi guys, so this tutorial will finish up our summary on the theory of database design, and next we'll be moving into implementation in the next set of tutorials. So logical design, or stage one, to stage one of logical design, translate the ER model into relations, and good design should avoid redundancy and anomaly. So those are the two things to watch out for. An anomaly is an error or inconsistency that may occur when a user tries to update a table with redundant data. Right, so this idea of redundant data and anomaly, they're sort of tied together. These are the different types of anomaly. We have 1, 2, and 3. Insertion anomaly, deletion anomaly, and modification anomaly. The goal of normalization is to decompose or split up relations or tables with anomalies to produce smaller, well-structured, without anomalies, relations tables. So we're taking tables that have anomalies and we're making them without anomalies. And that's the goal of the concept of normalization. Okay? Functional dependency is a constraint between two attributes or two sets of attributes. And to define this, we say that attribute B is functionally dependent on attribute A if for every instance of A, the value of A excuse me. Attribute B is functionally dependent on attribute A if for every instance of A, the value of A uniquely determines the value of B. And I missed the parentheses here. Each X value is associated with precisely one Y value. And here's the big question of today. Can an inclusive relationship have a discriminator? Of course not, because discriminator only occurs in an exclusive relationship. Remember, the discriminator was that, is sword. It was that Boolean variable. But if something is inclusive, it can be many things. So ruling out that something's not a sword doesn't mean, wouldn't necessarily indicate that it's not a double-sided sword. I mean, saying something is a sword wouldn't give us the specifics, right? So discriminators serve us they don't occur in inclusive relationships where an attribute can be of multiple types, or where a child attribute can have, in other words, we have an item here, yet where a parent attribute can be multiple, be multiple children types. So like we have an item, sword, health, arrow. For some reason, if something could be a sword and an arrow, right? The discriminator does us no good because our parent could have two forms. It could take on both these forms like almost conjoined. So we could have a sword arrow, right? If we're saying that something can be both a sword and an arrow. So we don't have discriminators in inclusive relationships, and so we wouldn't have the X there. All right, guys, and that concludes our theory behind database design. So the next group of tutorials will be focused on the implementation of the theory. See you guys in the next tutorial.